Happy Math Day! Welcome to Circle Christian School Supplemental Math Videos. Lines in a coordinate plane. The slope of a line in a coordinate plane represents the number of units the line rises or falls vertically for each unit of horizontal change from left to right. This is also known as rate of change. Miles traveled along a road, the time that it takes to travel the road. Items made, the dollars made from the sale of those items. Children's tickets versus the adult tickets at the school play. All of these have some sort of action-reaction to them, or what we call a rate of change. The rate of change is also known as the slope of a line in a linear equation. In coordinate planes, points that are plotted have some sort of relationship. Many times these relationships have functions. Today we're going to talk about linear equations in two variables. There are several things that you need to know about the equation of a line. These forms and formulas are best used when you commit them to memory. First is the standard form. ax plus by equals c. A, b, and c are real numbers. General form takes standard form and just sets it to 0. Slope-intercept form is probably the most popular form of a linear equation, mostly because in my world it means cupcakes. Point-slope form is actually when you have a point and a slope, and can also be used as a formula. The slope formula, or rate of change, is the action that happens to the points in the equation. This is the difference of the y's over the difference of the x. So far up and down, so far back and forth. I equate it with climbing stairs. Remember, at any time you can stop the video and take a look at the forms and formulas, write them down, or at least know where you should find them in your book. You'll use these a lot. Finding the equation of the line is one of the most favorite things that I do in coordinate planes. That means I get to make cake. There are two things that we need to find the equation of a line. Let's see if I can hear you. You need a point and you need a slope. Good job, people. Quite often, we're asked to find a particular type of equation of a line using parallel and perpendicular lines. Parallel lines have same slopes. I'm going to call M1, slope 1, equals slope 2. Perpendicular lines have slopes that are opposite sign and reciprocals, whereas that when you multiply them together, they always equal a -1. Okay, let's find the equations that are parallel and perpendicular to a particular line. In this case, 4x minus 2y equals 3, with the given point 2, 1. Since what we need are two things, a point and a slope, we're going to use our point-slope form in a formula way. Let's start with our perpendicular lines. I like to make a template. This way all the integers stay happy, don't get mixed up, and it really helps in solving things. So we're going to put in our information. We need a point and a slope, an x and a y. Great, we happen to have that. Put my x with my x, my y with my y. And now we need a slope. Oh, but unfortunately our equation is not in a proper form that we can distinguish what our slope is. So we're going to have to change our standard form into slope-intercept form. In other words, we have to get the y by itself. So that means I need to move the x. And anytime you move the x over the fence of equality, it always changes its sign. So now it's going to be a -4x added to the 3. Still got to get the y by itself, so we're going to divide out the -2. Some courses have you put it under the whole equation. I like keeping them separate. That way I can distinguish exactly what my slope is, which in this case is 2x, and what my y-intercept is, -3/2. Now, in all honesty, the only thing that we really needed was the slope at this time. The slope for the parallel lines is going to be 2, while the slope for the perpendicular line is going to be the opposite of that, which is negative, and a reciprocal, so -1/2. Now I can place my slope inside here, and we can solve for y equals mx plus b form. I'm going to distribute the 2, my wet ingredients, into the dry ingredients. I like writing from left to right, so you'll see me start with the very beginning here. If you have integer problems, I'm going to tell you, generally you may be bouncing around and should start to learn to do a little more left to right. Minus the 4. Still got to get the y by itself, so we're going to add the 1. They cancel out. We're going to get the y equals 2x minus 3, and we have found our parallel line. Sound effects for working the perpendicular line now. Okay, same thing. You're going to make a template. Y minus y1 equals mx minus x1. Plug in your data, plug in your point. X is with the x's, y is with the y's. Put your slope in. Remember that since this is perpendicular, it's an opposite reciprocal. And then we're just going to mix it all together. Okay, going to distribute. And again, I still like working from left to right. -1/2 x. Negative is a positive. 2/2 is a 1. Add our 1's just like we did before. And y is going to equal -1/2 x plus 2. And we now have our perpendicular line to our original equation, 4x minus 2y equals 3. Now, go out and make some cupcakes and share them with a friend. Have an awesome day.